Good morning. Let me explain you few concepts of matrices with one single example. So solving linear equations, linear algebraic equations which are simultaneous, echelon form, rank of a matrix, Gauss elimination, and Gauss Jordan. Now, these are the concepts we are going to discuss about linear system of equations. Suppose we have three equations, say a11x1 plus a12x2 plus a13x3 is equal to b1. a21x1 plus a22x2 plus a23x3 is equal to b2. a31x1 plus a32x2 plus a33x3 is equal to b3. Expressing them as a system of matrices. a11 into x1 plus a12 into x2 plus a13 into x3 is equal to b1. Similarly, a21x1, a22x2, a23x3 is equal to b2. a31x1, a32x2 plus a33x3 equal to b3. Now let us represent them as an augmented matrix. a11, a12, a13, b1, a21, a22, a23, b2, a31, a32, a33, and b3. Next is remove a21 from second row. Remove a31 from third. The steps are replace R2, multiply every element in R2 with a11, multiply every element in row 1 with a21. This makes the first element 0. So making a31 0. How do you make it? Replace R3 . Okay, by a11 into R3 minus a31 into R1. So this is the result of that elimination process. a11, a12, a13, b1 will not change. This becomes 0. So let it be a21 dash, sorry, a22 dash, a23 dash, b2 dash. This is 0. a32 dash, a33 dash, and b3 dash. Now make a32 0 and a12 0. Reference is second row. So first row 1 is replaced by a22 into row 1, this minus a12 into row 2. Okay. Next, make a32 0. So row 3 is replaced by a22 into R3 minus A22 into R3 minus A32 into R1, R2. What is the net result? Even first row will change now. A11 dash, this becomes 0. A13 dash, this becomes B1 dash. Second row is reference, so remains intact. Now third row will change. Okay. So two operations are performed here. So let it be A33 double dash, B3 double dash. Okay. Now one more thing is left. I want to make this to 0 by taking row 3 as reference. Now what are the equations now? Third row is reference. First row and second row will change. First row is replaced by reference is third row. So A33 into R1 minus A13 into R3. Next is A33 into R2 minus A23 into R2. The net result. Say A11 double dash 0 0 B1 double dash. Now this is 0. This is say A22. I don't remember whether it's single dash or double dash. Make it double dash 0 because of this operation. Next 0 0 A33 is a double dash. This is B2 double dash B3 double dash. Now rank is 3 because there are 3 non-zero rows. It is in echelon form. It is in diagonal form. You get the trace. Trace is sum of diagonal elements. And you got the solutions also for x1, x2, x3 straight away. So one method answering so many. What you got rank, you got trace. This is echelon form. And you got solution as well. Let us take the example of three equations. Say 3x1 plus 2x2 plus x3 is equal to 14. 2x1 plus 3x2 plus x3 equal to 13. x1 is 2x2 plus 3x3 10. So augmented matrix 3, 2, 1, 14, 2, 3, 1, 13, 1, 2, 3, 10. This is augmented matrix. 3 rows and 4 columns. Let us create one augmented matrix. We will do it semi-automatically by Python. To deal with new matrices, you need numerical Python module. This is not completely automatic, this is semi-automatic. So augmented matrix with 3 rows and 4 columns. First row 3, 2, 1, 14. Second row 2, 3, 1, 13. Third row 1, 2, 3, and 10. This is our augmented matrix. 3, 2, 1, 14, 2, 3, 1, 13, 1, 2, 3, 10. Okay. Now, elimination of coefficients of x1 from second and third equations. So what do you eliminate? You eliminate a21 and a31. So you know respective operations. So just seeing them now. So one more fact you should take care is rows are numbered as 0 to 1. This is the first row. This is the second row. And this is the third row. Okay. Now, second row is replaced by reference is first row. So 3 into 1 minus 2 into all elements in zeroth row. So you replay this video few times to understand what I'm doing. Or I just make it capital A to simplify the things. So row 2 replaced by A11 into row 1 minus A21 into row 0. Similarly, this is row 1. Reference is row 0. Next operation. Row 2 is equal to again 3 into row 2 minus 1 into row 0. So let us check the result after performing these two operations. You can clearly see that coefficients of x1 from second and third have become 0. Next step. Elimination of coefficient of x2 from first and third equations. So don't get confused. 1, 2, 3 in real life are 0, 1, 2 in programming lexicon in many languages. Please remember that. Now, when I say row 0, it is practically row 1. Now, reference is this. And we will be eliminating this 2 and this 2. Fine. Now they have become now 2 and 4. Okay. So row 1 is reference. Row 0 is equal to 5 into row 0 minus 2 into row 1. I'm sorry, not rows, they are named as A. First row is equal to 5 into first row minus 2 into second row. Second row is A1. Similarly, the last row. Reference is second row, 5 into that row minus what's the coefficient there? 4. 4 into the reference row. Check the result. Now you got 2 zeros in column number 2. Next, and the last. Elimination of coefficients of x3 from first and second rows. I mean of x2 from 0th and first rows in computer lexicon. Now, row 0 is equal to reference is third row. It's their coefficient is 36. 36 into row 0 minus 3 into that row. Next, row 1 is equal to, again reference is 36. 36 into this row. So 36 into 1, 36 minus 1 into 36. 1 into 36. So check. Now you got the echelon form. There are 3 non-zero rows. Okay. So rank is 3. What is x2? 36 by 36. And what is x1? 360 by 180. And what is x2? Sorry, x0. 1620 and divided by 540. Now print them. x0, x1 and x2. x2 comma x1, 36 by 36. Oh, this will do now. I'm sorry, I did not create X matrix. Let us create X matrix and then do it. So x0 is 3, x1 is 2, and x2 is 1. This is the solution. Okay? Could you understand now? One single method gives you so much of in-depth information. Echelon form, and then rank, and then solution. Is this fine? Hope you understand it.